Imagine a world where computers can recognize your face. They can translate languages instantly. This isn't science fiction. This is the power of neural networks, the engine driving a revolution in artificial intelligence. From self-driving cars to personalized medicine, neural networks are changing how we live, work, and interact with the world around us. Get ready to unlock the secrets of neural networks and discover the amazing potential of AI. Neural networks draw inspiration from the human brain. Just like our brain learns from experience, neural networks are trained on vast amounts of data. Think of a child learning to ride a bike. Through trial and error, they adjust their balance and coordination, eventually mastering this skill. Similarly, neural networks learn through a process of optimization, adjusting their internal parameters to improve their performance on a given task. By adjusting these weights, the network learns to prioritize important information and make accurate predictions. At the heart of every neural network lies a surprisingly elegant structure. Imagine a network of interconnected nodes, much like a spider web glistening with morning dew. Each node represents an artificial neuron, a simple yet powerful processing unit. These neurons are organized into layers, much like the layers of an onion. The outermost layer, the input layer, receives information from the outside world. The innermost layer, the output layer, produces the network's final decision or prediction. Each neuron in a neural network is a miniature decision maker. It receives signals from other neurons, performs a simple calculation, and then sends its own signal onward. This intricate dance of signals is what allows neural networks to learn and make intelligent decisions. A neuron's calculation is based on the weights assigned to its connections. These weights determine the importance of each input signal. The neuron then applies an activation function to its calculated output. As information flows through a neural network, each layer extracts increasingly complex features. The first hidden layer might detect simple edges or patterns in an image. Subsequent layers might then combine these features to recognize more complex shapes, like circles or squares. This hierarchical representation of information is what allows neural networks to tackle sophisticated tasks. Deeper networks can capture more abstract and nuanced patterns, leading to more accurate predictions and more sophisticated decision-making. The journey of information through a neural network is a transformative one. Raw data enters the network, and through the intricate dance of neurons and the interplay of layers, it is transformed into meaningful insights and predictions. They can take noisy, unstructured data and extract hidden patterns, revealing the underlying structure of the information. This ability to find order in chaos has profound implications for a wide range of applications. What truly sets neural networks apart is their remarkable ability to learn from experience. Just as a musician hones their craft through practice, a neural network refines its performance by adjusting its internal parameters based on the data it encounters. This process of learning is at the heart of artificial intelligence, allowing machines to adapt to new situations, make predictions, and even exhibit creativity. The key lies in the network's ability to adjust the weights associated with the connections between its neurons. Through a process of trial and error, guided by sophisticated algorithms, the network learns to adjust these weights, optimizing its performance on a given task. Section 2. Supervised learning, guiding the network to success. One of the most common approaches to training neural networks is called supervised learning. Imagine a teacher guiding a student, providing feedback and correcting mistakes along the way. In supervised learning, we provide the network with a set of labeled examples, each consisting of an input and its corresponding desired output. The network's task is to learn the mapping between the input, which is the image, and the output, which is the digit label. As the network processes each example, it compares its own prediction to the correct label. If the prediction is incorrect, the network adjusts its weights to reduce the error. Section 3. Unveiling hidden structures. The power of unsupervised learning. While supervised learning relies on labeled data to guide the network's learning, unsupervised learning takes a different approach. Instead of being told what to look for, the network is tasked with discovering patterns and structures within the data itself. Imagine a detective piecing together clues at a crime scene. In unsupervised learning, the network is presented with unlabeled data and must find its own way to make sense of it. This might involve identifying clusters of similar data points, reducing the dimensionality of the data, or learning to generate new data that resembles the input data. Section 4. Backpropagation, fine-tuning the network's mind. Central to the learning process in neural networks is a powerful algorithm called backpropagation. This algorithm, like a skilled sculptor meticulously chiseling away at a block of marble, allows the network to fine-tune its weights and improve its performance. Backpropagation works by propagating the error signal back through the network, from the output layer all the way to the input layer. As the error signal flows backward, it is used to calculate the contribution of each weight to the overall error. By adjusting its internal parameters in response to feedback, the network becomes increasingly adept at the task at hand. Section 5. The art of optimization, finding the perfect balance. Training a neural network is an art as much as it is a science. Finding the right balance between the network's architecture, the training data, and the learning algorithm is crucial for achieving optimal performance. One important consideration is the network's capacity, or its ability to learn complex patterns. A network with too few neurons or layers may not be able to capture the nuances of the data, while a network with too many neurons or layers may overfit the training data and fail to generalize to new examples. Another important factor is the learning rate, which determines how aggressively the network adjusts its weights in response to errors. A high learning rate may lead to faster learning, but also increase the risk of instability, while a low learning rate may result in slower but more stable learning. By fine-tuning the network's parameters, we can unlock its full potential. Section 1. A world transformed by neural networks. Step into a world where the impossible becomes possible, where machines transcend their limitations and begin to mimic the very essence of human intelligence. This is the transformative power of neural networks, a technology that is rapidly reshaping our world in ways we are only beginning to comprehend. From the mundane to the extraordinary, neural networks are leaving their mark on virtually every aspect of our lives. Consider the seemingly simple act of unlocking your smartphone with a glance. Behind this seamless interaction lies the intricate work of a neural network, trained to recognize the unique contours of your face. Section 2. Unlocking the potential neural networks in action. The applications of neural networks are as diverse as the human imagination itself. In the field of transportation, self-driving cars, guided by the intricate calculations of neural networks, promise to make our roads safer and more efficient. Imagine a world where traffic jams become a distant memory, replaced by a seamless flow of autonomous vehicles. Beyond our physical world, neural networks are also transforming the digital landscape. Recommendation systems powered by AI curate our online experiences, suggesting movies, music, and products tailored to our individual tastes. Section 3. The future unfolds, neural networks and beyond. As we stand on the cusp of a new era of artificial intelligence, the future of neural networks is filled with both promise and uncertainty. Will these powerful tools continue to augment our capabilities, or will they eventually surpass human intelligence altogether? As neural networks become more sophisticated, it is crucial that we consider the ethical implications of their development and ensure that these technologies are used responsibly for the benefit of all humankind. Section 4. Join the journey. Exploring the frontiers of AI. The world of artificial intelligence is constantly evolving, with new discoveries and breakthroughs emerging at a rapid pace. This is not a journey for passive observers. It is a call to action for all who are curious, creative, and eager to shape the future. Whether you are a seasoned engineer, a budding entrepreneur, or simply someone with a thirst for knowledge, there are countless ways to get involved in the world of AI. Explore online courses, attend industry conferences, and connect with others who share your passion for this transformative technology. The future of AI is not predetermined. It is a story that is still being written. Section 1. The dawn of a new era. As we conclude our exploration of neural networks, we find ourselves standing on the precipice of a new era. The world around us is being reshaped at an unprecedented pace, driven by the relentless march of technological innovation. Neural networks, with their uncanny ability to mimic and even surpass human capabilities, are at the forefront of this revolution. The future, once a distant horizon shrouded in uncertainty, is now unfolding before our very eyes. Section 2. Shaping the future, one question at a time. The power of neural networks lies not just in their ability to process vast amounts of data, but also in their capacity to learn, adapt, and evolve. They are not static tools, but rather dynamic entities, constantly being refined and redefined by the questions we ask of them. Do we seek to create machines that can automate our work, freeing us to pursue more creative and fulfilling endeavors? Or do we fear that such automation will lead to widespread unemployment and social unrest? Do we embrace the potential of AI to diagnose diseases and develop personalized treatments? Or do we worry about the ethical implications of algorithms making life or death decisions? These are not easy questions, nor are there simple answers. But they are questions we must grapple with as we navigate this uncharted territory. By engaging in thoughtful dialogue, by challenging our assumptions, and by remaining open to new perspectives, we can harness the power of neural networks to create a future that benefits all of humanity. Section 3. Stay curious, stay connected. The field of artificial intelligence is constantly evolving, with new breakthroughs and discoveries emerging at a dizzying pace. What we know today may be obsolete tomorrow, and the only constant is change itself. In such a dynamic landscape, the most valuable asset we possess is not knowledge, but rather curiosity. Embrace the unknown, question the familiar, and never stop learning. Explore online resources, attend conferences, and connect with others who share your passion for this transformative technology. The journey of understanding neural networks and artificial intelligence is not a solitary pursuit. It is a collaborative endeavor that thrives on the exchange of ideas, perspectives, and insights. As we venture further into the realm of artificial intelligence, let us do so with a sense of wonder, responsibility, and a commitment to using these powerful tools for the betterment of humanity. The future is not something that happens to us. It is something we create together. One question, one connection, one breakthrough at a time. Remember to like this video and subscribe to our channel to join us on this incredible journey of exploration and discovery. And be sure to let us know in the comments what other topics in the world of AI you'd like us to explore. Until next time, keep questioning, keep learning, and keep imagining.